Hi, and welcome to Coffee with Enyx. In this second episode, we will talk about the life of a trade with our full FPGA trading engine solution, nxAccess. Some of you may know us from our other solution, our full hardware feed handler, Enyx Feed, our full hardware bandwidth management solution, Enyx Link, or our more recent FPGA development framework, Enyx Framework. But as mentioned earlier, today we'll talk more about our full FPGA trading engine solution, nxAccess. On this first diagram, you can see that within the FPGA, you have three main blocks. First, a full hardware feed handler that comes straight out of our Enyx Feed solution that has been in production for 7 years. Second, a sandbox in which you will be able to drop your business logic right within the FPGA. And last, an execution engine that will allow both the hardware and the software to send orders to the exchange. Those three blocks have software equivalents. The full hardware feed handler has a C++ API that allows the trading application to configure and monitor it, but also to receive live market data updates. Your trading application running on the software is able to have live communication with the hardware business logic, not only to monitor it, but also to adjust trading parameters if needed. Finally, the execution engine has its C++ API as well that will allow the trading application to configure it, but also send orders to the exchange directly. The goal of this presentation is really to dive into why this hybrid implementation using a full FPGA data path as well as a software one bring out the best of both worlds in terms of latency using the FPGA and flexibility using software. So let's dive in. In this diagram, you can find the three blocks that we just saw. On the left, the feed handler, in the middle, your sandbox with your logic, and on the right, the execution stack. On the bottom right, you have the software component, which is the business logic or the trading application. So first, what the business logic is going to be able to do is, using the C++ API of the execution stack, preload data within it. Those data can be full orders or template of orders, and of course the goal is to allow you to preload more than one. You can preload up to 16,000, but in this example, we will limit ourselves to 3. As you can see with those 3 orders, the mass cancel order is a fully formed order that will be set as is. But you also have template of orders with missing fields like the buffer 1 that is missing a symbol, a price, and a quantity, which will allow the hardware business logic to provide those at the time of trigger. So when everything is set up on the execution side, then we can start looking into events that will create a trigger. In this example, we will focus on market data triggers, but the solution allows you as well to have triggers from your private feed coming from your TCP sessions. So when market data starts to flow within the FPGA, the feed handler will decode it and normalize it, perform A/B arbitration, build the book, and then distribute the data both to the hardware and software applications. When that happens, looking into the hardware business logic in particular, that can lead to a trigger depending on the configuration of your algo and the signal that it is looking for. As we mentioned before, when a buffer is triggered, you can also mention additional fields for the execution stack to consider when sending that order. So in this example, the business logic is going to trigger the buffer 1 and provide IBM as a symbol, $120.54 for the price, and a quantity of 75. When the execution stack receives that, it will then select the buffer 1, update it, and when it's updated, then it will send it to the exchange. So once again, it really happens in 3 steps. First, the software business logic is using the software API to preload data within the FPGA. Again, up to 16,000 orders or template of orders. Then a trigger can happen reacting to market data or private feed data. When that happens, that trigger can select a buffer, but also add fields for those orders to be updated. When everything is updated, then the execution stack sends that order. Alright, in this new diagram, we will focus really on the execution stack because there are a few things that were left out from the previous diagram. When you're dealing with order execution sessions, there are other things that the FPGA has to manage to be able to allow both the hardware and the software to send orders right through the same sessions. And one thing, obvious thing, is the sequence number. And we wanted to add an example to show how that sequence number can be specified by the software business logic through the API. So the first thing is, using the API, the software application can initiate a TCP session with the exchange. When that happens, then you're able to define what is going to be your sequence number. The API will then allow the application to preload those within the FPGA, and you can see it at the bottom right of the execution stack. Then, like before, we will preload data within the stack. When the data is preloaded, then a trigger can happen, and you will see from the hardware business logic on the left, that a trigger happens providing additional fields for the order to be updated. As mentioned before, collection 1 is selected and the fields are updated. But that's not all. Of course, you need to finish formatting the order. First thing that you need to do is, of course, have a TCP header, but you need to update the sequence number and update the one that is going to be used for the next order sent on that session, update the order IDs provided by the software application, and then finally calculate the FCS. When all that is done, then the order can go out. Alright, now that we've talked about all this and how great it is and how easy it is to have a strategy running in the FPGA, the next question is, how do I develop my FPGA strategy? And for this, there is really 3 ways. The first one is do it yourself. We will provide you a full reference design with examples and scripts that will allow you to develop your algo, simulate it, and synthesize it to get a firmware that you can then deploy into production. The second option is a jumpstart, where let's say you have this goal of 100%, you provide a specification for 80%, and Enyx is going to work to develop that and then hand it over for you to finish it for those last 20%. Of course, most of the times, those 20% are your secret sauce, what you want to keep for yourself. But what this option really provides is a very good time to market, because we can help you get there. Finally, the last option is Enyx manage everything. We develop your algo according to your specs, and we maintain it if your algo evolves or if the protocols, the market data protocol, execution protocol gets updated. Finally, one last thing about languages. On the software side, as we've seen, the libraries are C++. And on the hardware side, we can really work with either HDL or HLS. So HDL, like VHDL or Verilog, and HLS, which is a C++ based language that allows software engineers to join the effort of reducing latency of trading strategies. I really hope that this video gave you a better understanding of what we can provide with nxAccess. And of course, feel free to reach out if you have any question. We'll be happy to talk more about our solution and how it can help. Thank you. See you later.